This video is part 2 of 2 videos in which we're learning about decimals and the operations with decimals. The concepts and procedures introduced in the first decimals video will now be extended to division and order of operations. So you may wish to watch part 1 before watching part 2. So as we continue to look at operations with decimals, let's turn our focus to division. Let's use whole numbers first so we can make sense of what division can mean. And we'll explore 2 meanings of division. The first is to take a quantity like 12 and share it into a number of equal groups. In this case, 4 groups. And so we see that the answer is 3, and this answers how many in each group. Another meaning answers how many groups if we measure the size of each group. If we divide 12 into groups of 4, we see that we can make 3 groups. Another way to understand the meaning of measuring is to ask the question, how many 4s go into 12? For each of these 2 meanings of division, the answer is 3. Sharing answers how many are in each group, and measuring answers how many groups. Now what if instead of a whole number, we were dividing a decimal number, or dividing by a decimal number? Which meaning of division makes sense for each of these questions? We can take 1 2/10 and share it equally into 4 groups. To do so, first represent the 1 2/10 visually. Note that this is also 12/10. If we divide the 12 by 4, we get 3. So each group gets 3/10. For the question on the right, we can ask how many 4/10 make up 1 2/10. First, we represent 4/10. Then we take as many 4/10 as we need to make up 1 2/10. We can see that it takes 3 of them. We can also make sense of these questions using a number line. We can place 1 2/10 here. Next, let's divide this interval into 4 equal parts. We can see that each divided interval is 3/10. For the question on the right, we find 4/10 and then see how many of this interval it takes to make up 1 2/10, and we see that it takes 3 of them. This next example not only divides by a decimal, but will also have a decimal answer. First of all, we should recognize that for dividing by 6/10, it makes sense to consider measuring as the meaning of division. With that in mind, how many 6/10 do you think go into 1 92/100? As a first step, let's represent 1 92/100 visually. Next, in order to represent 6/10, we need to realize that it is equivalent to 60 hundredths. Now let's see how many of these 6/10 go into 1 92/100. There's 1, another 1, and a third 1. But the remaining piece is smaller than 6/10. So instead, we need to see what fraction of 6/10 this remainder is. We can see that it covers 12 of the 60 parts, but to express this as a decimal, we need to have an equivalent fraction in tenths or hundredths. Visually, we can see that it covers 2/10, which we can represent as 0.2. So altogether, it goes in 3 2/10 times, and this is our answer to the division question. Here is one way that we can represent the solution process using only numbers, or what we call solving symbolically. We saw that we can fit 3 of the 6/10 into 1 92/100, and 3 of the 6/10 amounts to 1 8/10. This left us with the remaining 12 hundredths. If we multiply the 6/10 by 2/10, we can then remove the remaining 12/100. Altogether, we have used 3 and 2/10, so that is our answer. This process is a type of long division. Notice that we could have broken up the 1 and 92/100 into more parts if needed. You may recognize this alternative approach, which gives the same answer because dividing 1 and 92/100 by 6/10 is equivalent to dividing 19 and 2/10 by 6. Let's apply what we have learned about dividing decimals to a problem. Sharing a restaurant bill is a common situation for dividing decimals. In this scenario, they are equally dividing the total bill of $42.15 among 3 people. For the purposes of this problem, let's assume this already factors in a tip. How would you solve this problem? Among the meanings of division we should consider, sharing makes the most sense. We need to split the total 3 ways. I'll also show the symbolic approach at the same time. Let's start with $10 each as a starting amount. So in total, we reduce a bill by amount of $30 and have $12.15 left to split. That's close to 12, so let's have each one pay $4 next. Subtracting $12 from the balance leaves 15 cents. Divided 3 ways, that means that each person needs to add a nickel to bring the balance owing down to 0. So each person should contribute a total of $14.05. Here we see 2 approaches. How do these 2 approaches compare, and which do you prefer? If the problem is dividing by a number that has more than 1 digit, then it is expected that a calculator is appropriate to use. In these 2 videos, we have explored both multiplication and division of decimals. Now it's time to bring all the operations together and learn about what order to do them in. When there are several operations together in one expression, we first evaluate parts that appear in brackets. Next, we do any multiplying or dividing. And finally, we do adding and subtracting. Let's apply this order to evaluate this expression. The steps along the way may be done by hand, mentally, or using a calculator. First, we look at the expression in brackets, which is the sum of 1 and 6/10 and 8/10, and that is 2 and 4/10. Next, we look for multiplication and division, and there are 2 expressions to evaluate as shown. We are now just left with addition and subtraction. How could you finish answering this question? We are to do the adding and subtracting in order from left to right, so let's first do the sum. This evaluates to 7 and 74/100. A strategy we can use to figure out the difference between these 2 numbers is to count up from the lower number. Starting at 2 and 58/100, I can add 2 more hundreds to get to 2 and 60/100. I can then add 14/100 to get to 2 and 74/100. And finally, I can add 5 to get to 7 and 74/100. Altogether, the difference is 5 and 16/100. Let's apply what we have learned about the order of operations to solve problems. Jennifer ordered 3 cheeseburgers and 5 hot dogs. She handed the food vendor $40. How much change should she get back? How would you approach solving this problem? First, to figure out the cost of the cheeseburgers, we need to multiply $5.50 by 3. A helpful way to think about this is to multiply the dollars and cents separately. Next, to figure out the cost of the hot dogs, we need to multiply $3.75 by 5. We can split the $3.75 into parts to make it easier to multiply. This works out to $18.75. The two amounts total up to $35.25. To figure out the change, we can count up to 40. First, add 75 cents to get to $36, then add $4 to get to $40. Altogether, Jennifer will get back $4.75 in change. We solved this problem in a natural, if not obvious, order. Let's look back and notice how it follows the order of operations. First, we had to do what was in brackets, which is to figure out the total cost of the burgers and hot dogs. Next, we used multiplication, then addition to finish off the value of what was in the brackets. Finally, we subtracted from 40. Our final example is a more interesting type of problem. Here are 4 decimal numbers. The blank squares can be filled with any 3 of these 4 operations. Which placement will give the largest answer? Take some time to try to solve this problem. With these numbers, subtraction will only make the answer smaller, so we won't choose to subtract. We could just try placing them randomly and see what answer we get, and then try all of the combinations. No doubt we could find the correct answer this way, but it is a lot of work, and the purpose of a good problem is not as much about getting the right answer as it is about thinking mathematically and strategically. So let's try a more strategic approach. The 2/10 is the smallest number, so we should think carefully about which operation we could pair with it. Division is a great choice because dividing by 2/10 means how many 2/10 go into a number, and that means that it'll be 5 times for every one. Next, we should think about where the multiplication should go to get the largest result. In either place, a number will be multiplied by 6/10. So in a choice between 2 and 5/10 and 1 and 4/10, we should choose 2 and 5/10. So the addition has just one place to go. Now we just need to apply the order of operations to determine the final answer. There are no brackets, so we need to multiply and divide first. Multiplying by 2 and 5/10 by 6/10 gives us 1 and 5/10. Dividing 1 and 4/10 by 2/10 gives us 7. Finally, we add these together and get our answer, which is 8 and 5/10. Here's an interesting extension to this problem, which is, what if we could add a set of brackets? Can you make a larger answer? Placing brackets here or here will not change our answer, since we already did those operations first, even without the brackets. So let's look at the 3 other possibilities and evaluate each. We can then think strategically in order to estimate. All of these involve multiplying by 5, so clearly it is the bottom one which is the answer. The answer is 25. This video addresses several learning standards in the Mathematics Grade 7 curriculum. Throughout the video, we use decimals to represent and describe parts and wholes of numbers. We also extended division of whole numbers to make sense of dividing decimals. In this content standard, we focused on dividing decimals and order of operations. As your child learns about multiplying decimals in their classroom, several curricular competencies may emerge. For example, we represented dividing decimals at first using pictorial forms and then symbolic. Visualizing was a helpful way to make use of 2 meanings of division when using decimals, And finally, for most questions, we explored multiple strategies to solve each problem. We hope that you found this Part 2 video valuable in helping you support your child in their learning about dividing decimals and the order of operations. Be sure to check out the other titles in this series.